high-speed steel tool at room temperature. Its color is silvery bright، يعني فضي لامع أو فاتح. لكن لو إن التمبريتشر زادت عليه الكلر will be changed. Colors as temperature raises up. How rises this? Colors as temperature rises، يعني كلما يزيد temperature، يعني every time the temperature rises up, the color will be changed from silvery to bright yellow, then dark yellow, then after this brown, طبعا bright, then dark, then black. Okay? Once the color be changed from the room temperature to that one, it means that temperature is very high for the tool. Lower high-speed steel. We talk about high-speed steel tool. Therefore, I should keep the temperature of the tool at room temperature. How to do this? You should put your finger every second, every time, to feel the temperature. Of the tool. It shouldn't exceed يا إخوة. شوف خلي بالك أنا محافظ على إن to nose doesn't exceed or be higher than the basic reference plane، صح؟ It is on the same basic reference plane. Then أصلاً I got the tool this shape, one plane on the top plane, okay? And then I dig here by grinding. I remove this material by grinding. If you put the tool nose up, from where? You put it from the market like this. How to put the nose up? How for the nose to be up? Okay, شباب? زين. Every time I put my finger here, if I can sustain the temperature, then it is good temperature. But if I cannot touch here due to high temperature, then the tool is in danger. Okay, but what will happen if I leave the tool growing up in temperature? What will happen? Rapid wear will take place here until the tool will lose this part. The tool will lose this part and it will be like this. What happened? The workpiece cut the tool. And if the temperature raised up, then the hardness of the tool, the grain hardness of the tool, it will be low, and at the end it will be less than the hardness of the workpiece. Therefore, the workpiece will be what? Will be the tool. At this temperature, the workpiece will be the tool. Then the tool will be a workpiece. Then the workpiece will cut the tool this shape. Of course, we don't wait until these grades of temperatures. We don't wait until this. Only we don't permit this color to come. And the tool should be normal color, unchanged. اللي هو مين؟ السيلفري. I should keep the tool color silvery as it is. Okay يا شباب؟ last time we said that the uncut chip area. Here I draw it for orthogonal. This is our orthogonal cutting. This is the tool. Either it has a straight shank like this, or it can take a thin shank. By this way, this is the cutting edge, this is the secondary cutting edge, then the shank is bent by this way, and this is the limit of the tool face. And this is the limit of the tool face. Cutting in this direction at feed rate FR, or F. This is the depth of cut. Depth of cut A, and here this length is the width of cut B. Kaba is 90 degrees. Kaba is 90 degrees because the feed in this direction, cutting is edge in that direction, therefore the angle is 90 degrees. Then the Kaba equal to 90. After one revolution, if I take here, magnifying this corner here, this is the tool, cutting here, magnifying. After one revolution, and this is the depth of cut. After one revolution, I expect the tool to be here after behind the distance. At a distance F. And that one E, 90 degree, يعني it is rectangle. Here this distance equal to B, and the T naught اللي هو uncut shape thickness is that one. Therefore from the figure I can find that اللي هو uncut shape area. An uncut shape area has 4 sides. Every 2 are equal. I can say that for orthogonal, F equals to T naught, depth of cut equal to the B. And if you return back for the last lecture, for the oblique relationships, we have A equal F sine Kaba. T naught equal F sine Kaba, and A equal to P sine Kaba. By this way, both here is what? Both here, sine Kaba, sine 90, or sine 90, and here 90. We get these equations. Then sine 90 can 1. Okay, sine 90 equal 1. And how much is the area? This area, how much? Any two perpendicular two sides. Any perpendicular two sides multiplication. Either we say, can we say A to F, or even B to F, okay? Or from other side, T naught to B. Either this or that. Here also it was the same. Here also it was the same. A naught in oblique equal to left P A في الA اللي هو parallelist كان parallelist بهذا الشكل was like this, and we said any perpendicular sides like this. Here A normal to F يبقى A في F this area, or the other way B perpendicular is the T naught here, T naught, okay? وبالتالي T naught في B. It is the same value of A naught and orthogonal. If you look at any machining process, how to judge that it is proper or improper? And how to judge that the machining process is going or running on properly? Number one, if it has low noise, no noise, but low noise, Number 2, low vibration. Number 3, normal cutting forces. Number 4, normal temperature, normal cutting temperature. Number 5, required surface finish. If you are adjusting for finishing, then you should get the required surface finish, or otherwise the process going wrong. Okay? These are the characteristics of proper machining process. Interning. This is the workpiece X, and the tool is cutting here, having clearance like this, and it has a tip 90 degree. This is the tip, and the tip is held on shank, 90 degree tool, 90 degree tool. Kaba here is 90 degree. What is the depth of cut in case of facing? This is the depth of cut. This is the depth of cut in facing. From here to here is the depth of cut, and feed in this direction. Cross feed, not longitudinal feed, it is cross feed. Kaba in facing of this tool also can be smaller than or greater than 90. Here I will draw less than 90, Kaba less than 90. This is the tip, this is the holder. This shank here is tool holder, tool holder, while the tip is the tool itself. وبالتالي the tool face is the top surface of the tip. Okay? Where is the cutting? Depth of cut. Depth of cut here is like this. This is the depth of cut. A, doing machining. يعني إخوة, this surface, the lower outside one, the most right one, is unmachined. Is unmachined surface, and that one is the machined surface. Sorry. This is the machined surface. This is the machined surface, and this is the unmachined surface in facing, and you are going until the X, then we stop facing. Okay? Here also cross feed. How much Kaba? Kaba less than 90. This is the angle of Kaba. This is the main cutting edge, and this direction is the cross feed direction. Therefore, Kaba is that one, less than 90. Here, Kaba is equal to 90 degree. We can use another tool having greater than 90 by this way. This is the clearance, and this is the the main cutting edge, and this is the tip, 4 sides, and this is the holder, like this, and going also FC cross feed, and this is the Kaba, greater than 90. Depth of cut will be like this. This is the layer being cut from the end face of the workpiece. This is the depth of cut. واضح يا شباب؟ اوكي. طب في سؤال؟
دكتور الأخيرة الكهرباء بيسموه له
الكهرباء here. This is the main cutting edge. Kaba is that one. Greater than 90. About the tube cutting, we have a tube like this and we want to cut facing, doing facing or external turning, something like this. This is the tool, 90 degree to feed. Either bent shank tool or straight shank tool. Face up to here. لما تشوف face up to here يعني two lines معناها انه هو high speed steel or carbon steel. This is the feed direction. Depth of cut is this is the thickness. Thickness of the tube is the depth of cut. And the tool cuts here going this direction. Cover is 90. Orthogonal cutting. Okay? Orthogonal cutting here, orthogonal cutting here. And others are oblique. Volume of the material is removed. This is a very important parameter in cutting. It's called material removing rate. Material removing rate. Or you can say material removal rate. Material removal rate is written like this or like that. Either material removing or material removal rate. اللي هو denoted by MRR, and this value equal, this parameter equal to multiplication of the three parameters of cutting اللي هم ال V في ال F في ال A. ال V في ال F في ال A. واضح يا شباب؟ زين. ننتقل إلى الماشينينج تايم. In the workshop you have an exercise, and the exercise consists of many surfaces, and every surface needs a machining process. يعني it is like this. The first one, 25 diameter, then step 2, diameter 21.5. Then after that, I think there is an undercut, and then 14 for thread. 14. لا مش 14, 16. 18
undercut 14.
يعني هنا step and then undercut, then 16 of them.
14 plus 3.
14 length. 14 is length, then chamfer. That one 5, 16. Here length 14. Okay? Yeah, many 1, 2, 3, 4. 4 diameters. Therefore, how much raw material you have? We have 25 raw material. Therefore, this mesh I will not do it cutting, but this and this and that will do in cut. The first step to do, what is it? I will start facing. على مين؟ على 25. The raw material كده. Raw material. This is the raw material. The raw material is like this. Okay, the first step I will do facing. Greater than like this. عندنا هنا 1 millimeter facing. يبقى إذا في ماشينينج تايم للفيسنج، صح ولا لا؟ في ماشينينج تايم للفيسنج، خلينا نحسب الماشينينج. equal to هنسميه تي ام، هيساوي ال ستروك ديفايد على يو اور اف ار اللي هو الفيد ريت. هذا اليو او الاف ار ده بيسموه الفيد ريت. فيد ريت خدناه، نعم انا فاهم. اف ار بيساوي اليو سوري الان في الاف. اوكي؟ خلينا نوحد الكلام. هنا دي هي الاف ار. الاف ار اللي هو الفيد ريت، والفيد ريت بيساوي ان في الاف. لكن ما هي الستروك؟ الستروك I should start a little bit before الورك بيس. يعني I should put the tool facing. يعني الدبس اوف كات فين؟ الدبس اوف كات في هذا الصوب ولا في هذا الصوب؟ اكسيال ولا راديال؟ الدبس اوف كات for facing. Now I talk about facing. كان مرسوم قدامكم هنا من شويه. it is axial. احط التول بهذا الشكل صح؟ كفر 90 or less or greater than 90 اللي هو التول اللي كان شكله كده كنا لسه راسمينه الحين اوكي؟ بنش شانك تول بهذا الشكل. هذا هو الدبث اوف كات. هذا هو الدبث اوف كات. It will move cutting all of this. up to what يا اخوه؟ الترافل بتاعه up to الاكس. يبقى اذا ال ستروك هنا كام؟ ال ستروك في الفيسنج هيساوي كام؟ الراديوس بلس ران ان. ران ان اللي هي فين؟ اللي في البدايه اللي هي في السبيس في الهواء قبل ما يعمل تاتش مع الورك بيس. يعني سي مثلا 4 ملم 4 ملم. هذه ال 4 ملم كول ران ان. ران ان. هذا هو ال ستروك في الفيسنج. اقسمه على I will divide on اليو في الان. اليو سوري الان في الاكس. الان في الاكس. انسى اليو دي خالص انساها خلاص ما بقاش عندنا يو. هو اف ار. الان في الاف اوكي؟ طيب ده في الفيسنج. طيب any external turning or axial turning like this how to do it? The same. The same. I will put the tool here a little bit before the workpiece called run in plus how long it will move. صح كده؟ First of all, I will do the maximum diameter. اللي هو ده. I will do this one. All the workpiece. This is number one. This is number one. في machining number one. External. External. Right to an external. Turning. اللي هو part number one. Then I will do to this diameter. This is number two. Then I will do to the minimum diameter. This is number three. يبقى how many layers I will do? Every time 3 layers. Start from here up to here on the maximum diameter 21. واضح؟ Then I will do from here also كله من هنا من البداية من هنا. All the strokes will be start from here up to here for what? For the next diameter 18. Then up to here for the 16 diameter and so on. Therefore I will get T machining 1, 2 and 3 plus the tool machining of facing. And another machining time for what? For undercut, for chamfer. Undercut or chamfer, like mean, like facing, radial, like this, okay? Then the thread the same like that one. And we have how many machining time? We have 4 machining time for undercut, for chamfer, 4 thread. 1, 2, 3, 4, 5, 6, 7. Then at the end, don't forget to do what? To do the T machining time of the parting off. Every product is like this. Any product we machine is like this. Too much surfaces, too much strokes, too much machining time, but at the end, I can collect what? The total machining time. Total machining time equal to summation of all machining times موجودين for the product. مين مش فاهم؟ يعني the product here has too many surfaces and has to have too much surfaces to be cut. احنا نسينا كمان we forgot ان في هنا ايه؟ hole. This hole has also machining time. And I will write here also machining time of drilling. And so on. At the end, I will get total machining time. summation of all these times. All these times. The summation of it will give me the total machining time. Then I can calculate what's called productivity. Productivity, or you can say production rate. Production rate, يعني how many pieces يا إخوة I can produce per hour. This is the meaning. How many pieces of this one I can produce per hour. Not forget also في التمرين بتاعنا في exercise there was here knurling. Therefore
على وش نشتغل؟
knurling اسمها knurling K N U R L I N G knurling خشونة أو تخشين يعني you can see knurling في الهاندل of الميكرومتر في الهاندل of الميكرومتر because the people found في الوركشوب الناس اللي في الوركشوب oil is there and rotating the thread is difficult, therefore we do on the handle of the thread some roughness بالنيرلينج والنيرلينج ده is not cutting, it is forming. يعني we have two wheels like this having roughness here and the other one like this, the side view of the workpiece. Then are mounted on a lever, and this lever like the shank of a tool, and we put it on the tool post. We mount على tool post, and the workpiece is here. Then I press the two wheels. I press against the workpiece while it was rotating. It will give me the roughness on the surface. No cutting, only impressing and تعمل انطباع of the lines on the surface outside surface. Okay? يبقى دي كمان للنيرلينج.
عشان تسوي لك
نعم.
عشان تجيب الرف سيرفيس يعني.
To get rough surface for the handle of a thread. For the handle of a thread. زين. خلينا ننتقل على دي، خلينا نركز على دي. Productivity equal to 1 over the total machining time. The total machining time. I will return back again to these times. What are the units of these times, or every one of them? Minute, that 1 minute, that 1 minute, that one, all of them minute. Therefore السميشن بتاعه هيكون اليونتس بتاعه كام؟ minute، ولكن minute بالايه؟ انه توتال minute فوق بير بيس. مش واضح ها؟ هنا الماشين تايم اليونتس بتاعه كام؟ في الفيسنج minute. في الثريد مثلا 21 minutes. وهنا only 5 minutes, and that one 6 minutes, 60 minutes, 30 minutes, and so on. كله minutes صح ولا لا؟ طيب لما نجمعهم كلهم يطلع ايه؟ التوتال ايه؟ minutes بالايه؟ لان البيس يخلص في هذا التايم. This time is enough, okay, for one piece. Therefore, the units will be changed. The total will give me minutes per piece. طب لما نعمل الريسيبريكال لما نقلبه يعطينا ايه؟ بيس بير مينت. ولكن في المعتاد يا اخوه is given بيس او برودكت. انا متعمد اغير الكلمه، مره تسمعها بيس ومره تسمعها برودكت، لكن احنا عاده نقول برودكت بير اور، لان ما في برودكت يخلص في مينت. هل في برودكت يخلص في 1 minute؟ وبالتالي how many products finish in 1 hour؟ لكن دي minute بالبيس. فلابد من تحويل. This one اللي هي التوتال اهي minute بالبيس. لو قلبناها تطلع ايه؟ بيس بير minute. طب انا عايزها بيس بير اور. نضربها. وبالتالي I will change this one to what? To 60. ف 60 على توتال تايم يديني بيس بير اور او برودكت بير اور.
دكتور لكن هذا الشغل بيكون كله اوتوماتيك لا؟ لان احنا في الورشه عم ناخذ وقت زياده نبدل التول وكذي.
الفيد اوتوماتيك. الفيد هنا اوتوماتيك، كل الفيد اوتوماتيك لان احنا بنحسبه على فيد اوتوماتيك اللي هو ده محسوب على الفيد ريت اللي هو هنا اوتوماتيك. But about the other point اللي انت ذكرتها الحين tool changing, I can estimate how long time I will take to change the tool. I can estimate how long time I take to change the tool from this one to that one to this one to that one. Okay, and then how long time I will take to center or mount the workpiece. How long time I will take to mount the workpiece. How long time I will take to load down the workpiece. Load up and load down. Okay? And there's another estimated science should be added علشان يعطي لك cycle time of البرودكت. لكن الحين دلوقتي احنا بنقرب لكم الموضوع. يبقى 60 ديفايد على التوتال تايم يعطيني ايه؟ البرودكتيفيتي او البرودكشن ريت.